In a man-in-the-middle attack, an attacker redirects traffic between two hosts in order to intercept or modify it. There are many forms of man-in-the-middle attacks, including session hijacking, DNS spoofing, and SSL hijacking. ARP cache poisoning works because specially crafted ARP packets trick two hosts into thinking they are communicating with each other, when in fact they are communicating with a third party who is relaying packets in the middle. Here's how a typical ARP cache poisoning works. First, the attacker will send an ARP request asking about the victim's MAC address and pretending to be the router at the same time. Then the poor victim will respond happily back with his MAC address. The attacker is not done yet. In fact, he or she will send a second request telling the victim that the router MAC address is the attacker's MAC address. Wow. We will see this scenario in details during the packet analysis in the upcoming demo. Now here's our candidates for this lab. We have 3 hosts. The attacker is going to use Kali Linux at 10.0.0.222, and the victim machine will be a Windows 7 host at 10.0.0.101. Finally, the penetration tester will use Kali Linux to intercept all the traffic and analyze any attacks on the network. And his address is at 100. Let's begin. This is the hacker machine. Just to make things different, I set up a new desktop background, and the logged in user is hacker. Let's check together the IP address of this host. Because I'm logged in as a normal user, I will try to elevate my privileges first. The interface config command will do the job. Indeed, the hacker IP address is 222. Now let's see this bad hacker doing a man-in-the-middle attack. First, we need to configure the intercept system into the forwarding mode by appending the value 1 into the IP forward file. Let's double check the contents of this file. Good, the value 1 is saved. Now, it's time to start the ARP spoof commands. In this command, I'm telling the ARP spoof to use the interface Ethernet 0, followed by the IP address of the victim, and finally the IP address of the gateway. Now open a second window and execute the second ARP spoof command. In this command, I'm doing the inverse of the first one, because we need a two-way communications. The attacker can launch Wireshark and start listening on the victim's conversation. Let's switch to the victim's machine and see what's happening. Open the command prompt and check the IP address of the victim. We can see that the IP address is 101. You can validate that the spoof is working by executing the ARP command. Check this out. The gateway IP is pointing to the attacker MAC address. At this moment, the attacker is listening to all the conversations that the victim will execute with the outside world. The next step is to switch to the ethical hacker machine and try to catch this bad hacker. Let's verify the IP address of the pentester machine. Indeed, it's 10.0.0.100. Now let's open Wireshark and load the saved capture file for this lab. Wireshark is screaming, "Don't execute me with root privilege." I'm going to ignore it and click on OK. Click on the File menu, select Open, and I will select the captured file for this lab. If you have never seen Wireshark before, I invite you to check our library at Pluralsight because we have a course that teaches you the basics of Wireshark. We know that ARP cache poisoning is a technique that occurs at layer 2. So, if we just check the packets in the packet list pane, it may be hard to see any full play. In order to analyze this properly, we will add a couple of columns to the packet list pane. Up here in the menu, click on the Edit, then Preferences. Select Columns. Click the Add button to insert a new entry. This is going to be the source MAC address. In the Field Type drop-down list, select HW source address resolved. Unselect the length column and the time column too. Now let's add the destination MAC address column. After finishing, click on the Apply button, then click on the OK button. I forgot to put the columns in the right order. Let's go back to the columns, Preferences, and move the source MAC after the source column and the destination MAC after the destination column. Select both, click on Apply, then click on the OK button. Good job. At line number 15, a response from the victim to the attacker containing its MAC address information. This is what we just saw in the slides, right? The real voodoo here occurs in packet 3 on line number 17. When the attacker sends a packet to the victim with an ARP reply, telling it that 10.0.0.1 is located at its MAC address. The problem is that the MAC address of the router is not this one. The victim will now be sending traffic that should be going to the router to the attacker instead. Spooky. Now, in a real-world scenario, you have thousands and millions of packets at your fingertips. To check for an ARP poison attack, we simply set our filter to ARP.duplicate-address-frame. Then click on the Apply button. When we examine the data provided by Wireshark, we also see that the IP address 10.0.0.1 is being claimed by another MAC address. Under normal network operations, two systems should not be claiming the same address on the same network segment, particularly the address of the gateway.